To further decrease the frequency of emergency rollbacks caused by faulty production updates on your web application platform, beyond the gains already made through better testing, which two strategies should you implement? Option A, adopt a blue-green deployment strategy. Option B, utilize canary testing to roll out updates to segments of your user base. Option C, decompose the monolithic architecture into independent microservices. Option D, minimize the platform's reliance on relational database technologies. Option E, transition the platform's storage layer from relational to NoSQL databases. All right, so let's take a look at all of these options. First off, we know it's critical to decompose the monolithic architecture into independent microservices. Independent microservices allow for better testing and deployment of isolated changes, which can decrease the risk of introducing defects. Then we also want to consider a blue-green deployment strategy. A blue-green deployment strategy allows us to safely test a new version of a product on a separate production environment before switching over to it. This means we can detect problems before things go live. So remember, we always want to make sure that we're deploying changes in independent units as far as possible, and never rely on code outside of those changes to be changed. That means we should always start with decomposition and ignore everything else, and keep that decomposition in mind for all of our solutions. And decomposition is always the answer, so let's always start with that.
Let us examine the core concepts involved in this scenario. When managing a web application platform, deployment strategies play a crucial role in mitigating the risks associated with pushing new code to production. Even with thorough testing, unforeseen issues can sometimes slip through, making risk reduction deployment patterns and architectural choices important topics for maintaining application stability and ensuring smooth updates.
In my view, the correct answers are option A, adopt a blue-green deployment strategy, and option B, utilize canary testing to roll out updates to segments of your user base. Blue-green deployment and canary releases are industry-standard deployment strategies for minimizing risk in production environments. Blue-green deployment allows for near-instant traffic switching between two identical production environments, providing a fast and reliable rollback mechanism if issues arise. Furthermore, canary releases reduce the blast radius of a failed deployment by initially rolling out changes to a small subset of users, allowing for monitoring and automated rollback before a wider release. Option C increases operational and architectural complexity, which can often increase the probability of deployment failure rather than reducing it. Options D and E focus on data storage architecture, which does not directly address the stability and reliability of the software deployment process itself.